So today our topic body projected vertically up. Body projected vertically up. So this is a body when we projected vertically up, it will go to maximum height. Body projected vertically up. So here this is the body, it is going up. So when it reach maximum height, the final velocity will be zero. The final velocity will be zero. The acceleration is equal to minus z. These two conditions for when the body projected vertically up. That is final velocity is zero at maximum height, a equal to minus z. Why? Because a equal to minus z, if the body is accelerating in this direction, but the gravitational acceleration is opposite to the acceleration, so a equal to minus g. So for this, the first point already we discussed in last class. At maximum height, at maximum height, velocity equal to zero, but acceleration is not equal to zero. This is one point. Velocity is zero, acceleration is not equal to zero. Then, so what happens here? After reaching maximum height, the body gets final velocity zero, but acceleration is equal to not equal to zero. Next, so this is the body moving upward side. The total time taken is equal to t. In the last second, how much displacement is there? How much displacement is there? Here, see, so look here. So this is the body. Final velocity equal to 0, a equal to minus z. These are two conditions. So here at maximum height v equal to 0. At maximum height, after reaching maximum height, the body has maximum height, it is equal to 0, a equal to minus z. For we have to calculate last second displacement. Last second displacement. For example, it taken t seconds. So nth second, u plus a of n minus half. So it is in the last second. Just substitute one particular second, u equal to a of n minus half. So here u equal to minus g n minus half. So in last second, for example, takes n equal to last second, that means take 1, or the total journey is 5 seconds, take 5. Like that we can calculate last second displacement when we projected body upward vertically up. So next you just copy it at the second displacement when body projected vertically up. So conditions are final velocity is equal to a equal to minus 0. Next, so in this case, this is time of ascent, this will be time of descent. Time of ascent, time of descent. So here time of ascent equal to time of descent. Time of ascent equal to time of descent. So that is equal to TA equal to TD, that is equal to U by G. So total time, see when we projected vertically up, then comes down to the reach the body to the ground. So when it is going up, the time is time of ascent. When it is coming to ground, time of descent. So total time of flight is equal to 2u by g. 2u by z. So already we discussed these things. Just you copy it. So based on this, I am giving one problem to you. See, when we, if a body projected, with 20 meter per second velocity, how much height, reached by the body? If a body projected with 20 meter per second, velocity upward, how much height reached by the body? How much height reached by it? So here, so this is the body. So here, this is the body. See, we projected upward, u equal to 20 meter per second. So it will reach maximum height. H max. So how much maximum height reached by the body when we projected with 20 meter per second? So here at maximum height, final velocity is equal to 0, but initial velocity is 20 meter per second. In this case, a equal to minus z. Just to calculate the distance traveled by the body when we projected vertically up with 20 meter per second. So for this, we have the formula v square minus u square equal to 2as. So in this problem, so what is the, see what we have here, v square minus u square equal to 2as, u equal to 20 meter per second, v equal to 0, e equal to minus z, s equal to h max. Just substitute here and calculate. Come on, do it. So v equal to 0 square, u equal to 20 square, that means 400. 2 into p into minus z, that is equal to 10 h max. So 400 equal to minus 20 h max. So 20 you will get h max equal to 20 meter. H max equal to 20 meter. Is it visible? It is not visible. So I am writing here. Up to here it is clear. So what happens here? 400 equal to 20 h max. So that is equal to h max equal to 20 meter. So what is the problem here? If a body projected with 20 meter per second initial velocity vertically upward direction, how much height reached by the body? So we are projected with u equal 20 meter per second. It reached maximum height, and maximum height v equal to 0. The acceleration of the body is equal to a equal to minus z. H max we have to calculate. So this is the formula: v square minus u square equal to as. That is equal, just we calculate 20 meter. So just copy it. I will give one more problem. Okay. Next, if a ball projected with with 9.8 meter per second vertically up, the max height reached by the body will be. So this is one more question. So here this is the body, we are projecting vertically up, u equal to 9.8 meter per second, u equal to 9.8 meter per second. At maximum height v equal to 0, a equal to minus z. So we have for solution for this one, initial velocity is 9.8 meter per second. Okay, final velocity is equal to 0, a equal to minus z, that is equal to minus 10 meter per second square. Just substitute in this one 2 as. So this is the maximum height will be here, just h max. Now b square equal to 0 square, u equal to 9.8 meter square. Okay, then 2 into minus z. G also you just take, instead of 10 take 9.8 into h max. From this you can calculate easily h max. Is it or not? Just 9.8 whole square, that is equal to 2 into 9.8 h max. So 9.8 will be cancelled. So we will get 9.8 equal to, what happens here, 2 into h max. So here h max 9.8 by 2, that is equal to 4.9 meters h max. Just we calculate, I calculate just what the information we have, that is the important question here. U equal 9.8 meter per second, b equal to 0, a equal to minus. Just substitute in the v square minus u square equal to 2as. This is the kinematic equation we have. That is the third equation what we discussed. So this is one more question I given to you. Just copy it. Okay, next. Next, one more problem. If we if a ball projected vertically up vertically up with with some velocity with some velocity, the body reached the body reached 19 point, let's take it is 20 meters height, and its final velocity is equal to 0. So my question is find its initial velocity, that is u. This is the question. Just you read the question and do the problem. Read the question first. So what happens here? So what happens here? If a body projected vertically up with some velocity, the body reaches 20 meter height and its final velocity is equal to 0. Find its initial velocity u. So this is the case. Here u we projected with some velocity, final velocity is equal to 0. For vertically projected body, a equal to minus z. We have to find this one. H max we have, that is 20 meter. So just we calculate u. So already we have this, use this formula 2as. V square minus u square equal to v square minus u square equal to 2as. Just substitute here. 0 minus u square, 2 into minus 10, take g equal to minus 10 meter per second square, h equal to 20. So what happens here? Minus u square equal to minus 400. Is it or not? Yes. This gets cancelled. U square equal to 400. Then u will be 20 meter per second. Is there any confusion? Nothing is there. So what we projected with some velocity, it reached some height. After reaching some height, the velocity of the body will be 0. While going upward, vertical up, while going the body in vertical up direction, a equal to minus z. That I used here, a equal to minus z, that is minus 10. Is equal to 20 meter, maximum height will be 20 meter, u square equal because 20 meter per second. Just simple. Okay, nice. Just copy it. Okay, you just copy this, message me yes, then I will go to one more problem. I am rubbing here. So based on this information, vertically projected vertically up, I will give one MSET problem to you. Just write fast. A ball is thrown. A ball is thrown vertically upwards, from the ground ground, and a boy gazing out the window, observe it moving upward past him at 5 meter per second. If g equal to 10 meter per second square and the height of the window 10 meter above the ground, the ball travels through a height equal to. So this is a question.